Welcome to day 13. Today we are hunting zombies. In a microservices architecture, a container can be running but effectively dead. If the user service loses its connection to Postgres, the container doesn't crash, but every request to it will fail. If our API gateway or orchestrator doesn't know that the service is broken, it will keep sending user traffic into a black hole. So today we're going to implement Liveness and Readiness Probes. Liveness asks a question, is the app running? And then Readiness asks the question, can the app actually do its job? By building these into FastAPI, we allow our infrastructure to detect failures and automatically heal itself by restarting broken containers. Let's open our user service and add two new endpoints. So I'll close these two and go to the user service main.py and add two endpoints. So at the very top, we shall have some imports. But before that, I'll just tell about them. The first will be /health/liveness. And this one would be very simple. If the web server can return a 200 OK, then the app is live. The second will be /health/readiness. And this one does actual work. It will attempt to ping the Postgres database. If the database responds, we return a 200 status. If the connection drops or times out, we catch the error and intentionally return a 5 or 3 service unavailable. So I'm going to add the text import at the top from SQL. Then we continue. So at the very top, I'll say, let me reduce the terminal. I'll say import. I'll import text, right? It has to be from SQL model import text. Okay. I think I've imported SQL model somewhere. So I can remove this and then say comma import text. Then from FastAPI, we need to import response. Okay. And status. By the way, if you want a tutorial on FastAPI, I have one on this channel. So make sure you search it out. So import response and status. Then at the bottom, I am going to paste the endpoints to save time. Okay. So the first one I told you is health, liveness. Simply checks if the server is running and returns a status of live. And by default, it will be 200. Okay. Then, in fact, I can remove this comment or just leave it. Then this one, healthness, readiness. Okay. Checks if the service is ready to handle database connection. So I simply say session.execute text, select one. Okay. Which executes a simple ping to the Postgres database and returns a status that the DB is ready. If the database is unreachable, we return a 5 or 3 error. Okay, and saying status unhealthy with the detail, which is simply the error message to a string. Now we have to tell our infrastructure to actually use these endpoints. We open our Docker Compose YAML file and update the user service. We shall add a health check block, and every 10 seconds, Docker will use Python's built-in web request library to ping our new readiness endpoint. Let me just do that before I continue talking about it. So compose.yaml and the user service, which is right here at the bottom, I'll paste, okay, this health check. Okay, so, and like I said, this health check runs every 10 seconds, and Docker will use Python's inbuilt web request library, okay, which is URL lib, and it will use it to ping our new readiness endpoint. So you see it says URL lib request.url open, which is this health endpoint. Okay, And then if things fail, then we exit with 1, meaning failure. Exiting with 0 means success. Now, if it receives a 5 or 3 error 3 times in a row, Docker will automatically mark the container as healthy, rather as unhealthy. Now, if you combine this with Docker's restart policies, okay, or Traficky's routing rules, the system will automatically stop sending traffic to the zombie container and even restart it automatically. So I think you see how easy this is. So I'm going to spin up the container and try to prove that this works. The goal is simply to simulate a failure. So I need to clear my terminal and run the previous commands. Okay, let's give it time to build. Okay, let's try to wait for about 10 seconds. I'm not sure if I can count 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I gave it some time. Okay, but let's go to here and run docker ps. Let me expand this. So I want to show you the user service. Where is it? I see user service. It is healthy. Okay, this is good. Now I want to stop the database to simulate a crash. I will clear my terminal and say docker compose stop. Did we call it db? I think it's called db. Yeah, so db is stopped. Now let's wait for about 30 seconds for the health check retries to fail, because it has to retry 3 times. Then after that, we have to run docker ps again. I want to check, I don't know how I would have timed this. I should have got probably a timer or something. Let me try to use my phone. But as I'm speaking, I think we have spent a good number of seconds. Let me try to time for about maybe 20. I think we have spent more than 10. Okay. Wow, my timer is not doing what I want. I'll put 20 minutes instead of 20 seconds. All right, let's see. We should be close to the 30 seconds. But I think we're done, because right now my timer shows 9 seconds, 8, 7, 6, 5, 4, 3, 2, 1. Done. All right, let's now do this. So I'll do docker ps. Okay, and try to scroll up. Okay, look at that. It says the user service is now unhealthy. Very nice. Great, great, great. So our microservices are now self-aware. They know when they are broken. And right now, Docker Compose just labels them unhealthy. But what if a system could see that unhealthy label, instantly destroy the broken container, spin up a brand new one to replace it with 0 downtime? That is where we graduate from local development to the real world. So in the next phase, we're going to take this exact code base and deploy it into Kubernetes. So subscribe and let's go to production. I hope you've learned so many things, and you should be able to apply all these tools and concepts to your projects when necessary.